I'm Molly, and this is Physics 2212, Lab 5, Magnetic Braking with Faraday's Law. So the purpose of this law is to do observational and computational experiments by recording data in both those ways by dropping a magnet through a tube of aluminum foil. And then we're just going to record the times it takes to go through the tube. And then the principles we're going to use are the Biot-Savart law, Faraday's law, and Newton's second law, and then our results of the experiment are listed there. So this is the model we're using. We're going to use a magnet with the north facing downwards, and we're going to drop it into a tube. And then the assumptions are that the barred magnet represents a magnetic dipole, that air resistance is negligible, and that the aluminum foil tube acts as a non-ferrous conductive tube, and the only forces are gravity and the force from the loop. So this is the experiment setup, with the system being the aluminum foil tube, and the bar magnet, and the surroundings being everything else. And the procedure is going to be, we are going to assign the north pole using the magnometer app, and then we're going to drop that magnet with the north facing down into the tube, and we're going to record the time it takes to enter and then exit, and we're going to do that 5 times. So here are those trials, 5 of them, with the time in seconds that it took, and then the average time, and then the measurements of the tube. And then here's my code. This one is just setting the constants. This one is creating code for the magnet, and the magnetic field of that magnet, and then a calculation of the magnetic flux. And then just simulating the experiment that we did before, and calculating the average time it would take. So then here's the graph that I conducted of the amount of time it would take, and that can be compared to the results of our experimental model. So then just some discussion questions. If the resistivity of the conductor were reduced as close to 0 as possible, then the dynamics of the falling magnet would change. The current would increase, the magnetic force would increase, and it would take longer for the magnet to fall. And then if holes were cut into the tube, adding some airflow and adding another force, this would affect the currents. The induced current would decrease, the magnetic force would decrease, and the time it took for the magnet would fall would increase. And then just some conclusions that we can make from this experiment. Aluminum is a good substitute for copper tubes, and aluminum foil doesn't really generate external magnetic field, and that barred magnets are a good model of a dipole. And then just a source of error, an example of that was the potential timing being off by starting the stopwatch when visually seeing when the magnet fell through the tube could have been a source of error. That's it. Thank you.